Top 25 Java Interview Questions and Answers. In this video, we will explore the top 25 Java interview questions and their corresponding answers. These questions are commonly asked by employers and can significantly impact your chances of securing a job in Java development. Whether you're a beginner or an experienced programmer, this compilation will help you prepare effectively. We aim to enhance your confidence and knowledge, ensuring you're ready to tackle any Java interview scenario. 1. What are the differences between JDK, JRE, and JVM? The JDK, Java Development Kit, is a software development environment that provides developers with tools needed to create Java applications, including a compiler, debugger, and other utilities. The JRE, Java Runtime Environment, is a part of the JDK and contains the necessary libraries and components to run Java applications. It includes the JVM, Java Virtual Machine, which is responsible for executing Java bytecode. The JVM provides a runtime environment and enables platform independence by converting bytecode into machine code specific to the underlying hardware. This separation allows developers to focus on writing code without worrying about the underlying platform. 2. What are the key features of Java? Java offers several key features that distinguish it from other programming languages. First, platform independence is achieved through the Java Virtual Machine, JVM, allowing Java applications to run on any device with a J versus M second. Java is object-oriented, promoting code reusability and modularity. Third, automatic memory management through garbage collection reduces memory leaks. Fourth, Java has strong security features, including bytecode verification and the security manager. Additionally, its rich standard library provides a wide range of APIs for various tasks, enhancing developer productivity. 3. Explain the concept of object-oriented programming in Java. Object-oriented programming, OOP, in Java revolves around the concept of objects, which are instances of classes. Key principles of OOP include encapsulation, inheritance, and polymorphism. Encapsulation allows data and methods to be bundled together, protecting the internal state of an object. Inheritance enables a new class to inherit properties and behaviors from an existing class, promoting code reusability. Polymorphism allows methods to perform different tasks based on the object invoking them, enhancing flexibility. These principles facilitate modular and organized code development, making it easier to manage and extend Java applications. 4. Why is Java considered platform independent? Java is considered platform independent due to its write once, run anywhere, WORA, capability. This means that Java programs are compiled into bytecode, which is an intermediate representation that can be executed on any platform that has a Java Virtual Machine, JVM. The JVM interprets the bytecode and executes it on the host machine, allowing Java applications to run on various operating systems without needing modification. This abstraction from the underlying hardware and operating system makes Java a highly portable language, enabling developers to create applications that work seamlessly across different environments. 5. What is the role of the Java Virtual Machine, JVM, in running Java applications? The Java Virtual Machine, JVM, serves as an execution environment for Java applications. It translates Java bytecode, which is platform independent, into machine-specific code. This process allows Java programs to run on any device that has a JVM installed, ensuring portability. The JVM also handles memory management through garbage collection, optimizing performance by reclaiming memory used by objects that are no longer needed. Additionally, it enforces security by providing a controlled environment that isolates running applications, which helps prevent malicious actions. 6. What is a constructor? How is it different from a method? A constructor is a special block of code in a class that is called when an object of that class is created. It is used to initialize the object's attributes and set up any necessary resources. Unlike methods, constructors do not have a return type, not even void, and they share the same name as the class. While methods perform specific tasks and can be called multiple times on the same object, constructors are invoked only once at the time of object creation. Constructors can also be overloaded, allowing multiple ways to instantiate an object with different parameter sets. 7. Explain the difference between and equals. In Java, the operator checks for reference equality, meaning it verifies whether two references point to the same object in memory. In contrast, the equals method is intended for logical equality, allowing comparison of the values contained within objects. By default, the equals method in the object class behaves like equals, but most classes override it to provide a meaningful comparison based on object attributes. For instance, two different string objects containing the same sequence of characters will return true when compared using equals, but false with equals since they reference different memory locations. 8. What are access modifiers? List and explain each one. Access modifiers in Java define the visibility and accessibility of classes, methods, and variables. There are 4 main types. 1. Public. Members declared as public are accessible from any other class in any package. This is the least restrictive modifier. 2. Private. Members declared as private are only accessible within the class they are declared. This modifier provides the highest level of encapsulation. 3. Protected. Members declared as protected are accessible within the same package and by subclasses, even if they are in different packages. This modifier enables inheritance while maintaining some encapsulation. 4. Default. No modifier. Members with no access modifier are accessible only within classes in the same package. This provides a package private level of access. 9. What are static variables and methods in Java? Static variables are shared among all instances of a class, meaning they belong to the class itself rather than any specific object. They are initialized only once when the class is loaded, making them useful for defining constants or shared data. Static methods, on the other hand, can be called without creating an instance of the class. They can only access static variables and other static methods directly. This allows for utility functions or factory methods that do not require object state. Both static variables and methods are declared using the static keyword. 10. How does Java achieve memory management and garbage collection? Java achieves memory management through its built-in garbage collection mechanism. This process automatically reclaims memory that is no longer in use, helping to prevent memory leaks. The JVM monitors object references and identifies unreachable objects, which are no longer accessible. Once identified, the garbage collector frees up the memory allocated to these objects. This allows developers to focus on application logic without having to manually manage memory allocation and deallocation. Various garbage collection algorithms, such as G1, Parallel, and CMS, optimize performance based on application needs. 11. How do you handle exceptions in Java? What are the best practices? Handling exceptions in Java involves using try-catch blocks to manage errors gracefully. When a code segment that might throw an exception is placed inside a try block, the catch block can then respond to specific exceptions thrown by the code. It's essential to catch only those exceptions you can handle. Avoid catching generic exceptions. Best practices include logging the exception details, using custom exception classes for clarity, and ensuring that resources are released properly by using the try with resources statement. Always aim for meaningful error messages to facilitate debugging. 12. What is the difference between checked and unchecked exceptions? Checked exceptions are exceptions that must be either caught or declared in the method signature. These are subclasses of exception but not of runtime exception. For example, IO exception and SQL exception are checked exceptions. Developers should handle them to ensure robust code. Unchecked exceptions, on the other hand, are not required to be caught or declared. They are subclasses of runtime exception, such as NULL pointer exception and array index out of bounds exception. These exceptions typically indicate programming errors or logic flaws. Handling them is not mandatory, as they may arise from issues that could have been prevented through better coding practices. 13. How do you ensure thread safety in a Java application? Ensuring thread safety in a Java application can be achieved through various techniques. One common approach is using synchronized methods or blocks, which restrict access to shared resources, allowing only one thread to execute at a time. Another method is employing locks from the Java util concurrent package, such as reentrant lock, which provides more flexibility than synchronized blocks. Using thread-safe collections like concurrent hashmap can also help manage shared data safely. Additionally, applying immutability principles by using immutable objects can prevent unintended side effects from concurrent modifications. 14. Explain the difference between wait and sleep methods in threads. The wait method is used for inter-thread communication. When a thread calls wait, it releases the lock it holds and enters the waiting state until another thread invokes notify or notify all on the same object. In contrast, sleep long millis pauses the thread for a specified period without releasing any locks. Wait must be called within a synchronized block or method, while sleep can be called from any context. Handling interruption is crucial for sleep, as it can throw an interrupted exception, unlike wait, which requires an explicit lock release. 15. What is the use of synchronized blocks? Synchronized blocks in Java are used to control access to a particular resource by multiple threads. They ensure that only one thread can access the block of code at a time, preventing thread interference and memory consistency errors. This is essential in scenarios where shared resources are modified, such as updating shared variables or data structures. By using synchronized blocks, developers can maintain data integrity and avoid issues like race conditions. You can synchronize blocks on any object, which allows for more granular locking compared to synchronizing entire methods. 16. What are the differences between ArrayList and linked list? ArrayList and linked list are two commonly used implementations of the list interface in Java. ArrayList is backed by a dynamic array, allowing for fast random access to elements due to its contiguous memory allocation. However, it can be inefficient for insertions or deletions, especially in the middle of the list, as elements must be shifted. On the other hand, linked list is made up of nodes, where each node contains a data element and references to the next and previous nodes. This structure allows for efficient insertions and deletions at any position but incurs a performance cost for accessing elements, as it requires traversing the list. Choosing between them depends on the specific requirements of your application. 17. When would you use a hash map versus a tree map? A hash map is preferred when you need faster access and retrieval of elements since it offers average constant time complexity for basic operations like add, remove, and contains. It allows null values and keys, making it flexible for various use cases. On the other hand, a tree map is useful when you need a sorted order of the keys. It implements the sorted map interface and provides guaranteed log, n, time cost for the contains key, get, put, and remove operations. Use a tree map when you require navigable key sets or need to perform range queries. 18. What are generics in Java? Why are they used? Generics in Java are a language feature that allows developers to define classes, interfaces, and methods with a placeholder for a type parameter. This mechanism enables stronger type checks at compile time, reducing the risk of class cast exceptions at runtime. By using generics, you can write more flexible and reusable code. For example, a generic list can hold any type of object, eliminating the need for casting when retrieving elements. Generics also support type safety, making code easier to read and maintain, while enhancing performance by reducing the need for type checking during execution. 19. Explain the Java Reflection API and its use cases. The Java Reflection API allows programs to inspect and manipulate classes, methods, fields, and more at runtime. This capability enables dynamic class loading, which can be useful for frameworks that require runtime type information, such as dependency injection. Reflection can be employed to invoke methods dynamically, access private fields, and create instances of classes without knowing their names at compile time. Common use cases include serialization, object mapping, and creating sophisticated frameworks like Spring or Hibernate, which rely heavily on reflection for their functionality. 20. What are lambda expressions, and where are they used? Lambda expressions are a feature introduced in Java 8 that allows you to implement functional interfaces using a concise syntax. They enable you to express instances of single-method interfaces, functional interfaces, in a clear and concise way. Lambda expressions can be used primarily in the context of functional programming, particularly with streams and collections. They simplify the process of writing callbacks, event listeners, and other similar patterns by allowing you to pass behavior as a parameter. Common use cases include filtering, mapping, and reducing collections of data in a more readable manner. 21. How do you implement dependency injection in Java? Dependency injection, DI, in Java can be implemented using various frameworks, with Spring being one of the most popular. The core idea is to decouple the creation of objects from their usage. In Spring, you can define beans in a configuration file or use annotations like at component, at service, or at repository. The @autowired annotation is used to inject dependencies automatically. This promotes loose coupling and enhances testability. Constructor-based or setter-based injection can be employed, allowing for flexible wiring of dependencies. Testing becomes easier since you can mock dependencies without changing the code structure. 22. Can you describe your experience using frameworks such as Spring or Hibernate? I have extensive experience with the Spring framework, utilizing its dependency injection and aspect-oriented programming features to create modular applications. Spring Boot has simplified the development process, allowing for rapid application setup and integration with various databases. Hibernate has been instrumental in managing database interactions, leveraging its ORM capabilities to map Java objects to database tables. I have worked on optimizing queries, implementing caching strategies, and ensuring transaction management, which has greatly enhanced application performance and maintainability. 23. How do you optimize the performance of a Java application? To optimize performance in a Java application, start by profiling the application to identify bottlenecks using tools like Visual VM or JProfiler. Optimize algorithms and data structures for efficiency. Use appropriate collections and minimize object creation to reduce garbage collection overhead. Implement lazy loading for resources and consider using caching mechanisms for frequently accessed data. Tune the Java Virtual Machine (JVM) parameters according to application needs. Additionally, utilize multithreading and asynchronous processing to improve responsiveness and throughput. Regularly review and refactor code for better performance. 24. How do you ensure security in Java applications? To ensure security in Java applications, several practices should be implemented. Input validation is crucial to prevent injection attacks. Utilize secure coding standards, such as avoiding hard-coded passwords and using encryption for sensitive data. Implement access control mechanisms to restrict user permissions based on roles. Use Java's built-in security features, like the Security Manager and the Java Cryptography Architecture, JCA, to manage permissions and cryptographic operations. Regularly update libraries and dependencies to patch vulnerabilities. Finally, perform security audits and penetration testing to identify and remediate potential threats. 25. Can you explain a RESTful web service in Java? A RESTful web service in Java is an architectural style that utilizes HTTP requests to access and manipulate data. It is based on the principles of representational state transfer, REST, which emphasizes stateless communication and resources identified by URLs. In Java, frameworks like Spring Boot simplify the creation of RESTful services by providing annotations such as at REST controller and at request mapping. These services typically return data in JSON or XML format and support standard HTTP methods like GET, POST, PUT, and DELETE. RESTful services are widely used for building scalable web APIs. As we wrap up our exploration of the top 25 Java interview questions and answers, we hope you found this information valuable for your preparation. Mastering these concepts can significantly boost your confidence and performance in interviews. Remember, practice and understanding are key to success in any technical field. If you enjoyed this video and found it helpful, please give it a thumbs up and consider subscribing to our channel for more insightful content. Your support helps us bring you more valuable resources. Happy coding and good luck with your interviews.